Welcome back to More Fun with Finance. I'm Dr. William Elliott, coming to you from beautiful uptown Shaker Heights. So today we're going to be talking about Chapter 5. That's somewhat of the new material we're getting into. We're looking at MPV in particular, but also other types of investment rules. MPV is by far and away the best of the investment rules, but we're going to talk about the others as well. Just give you some idea of some of the problems, advantages and disadvantages of all of these. So, without any further ado, let me shift myself out of the way and get the slides up here for you all. So, it just gives you a little bit of a roadmap as to where we're going today. And we'll start by talking about MPV, go into payback rule, talk about IRR and some of the variations of IRR, in particular modified IRR. And then we'll talk a little bit about profitability index and then wrap things up. So, MPV. Basically, this is the gold standard. This is where we want everybody to be, but they're still not there. Largely because many of those who are in charge of corporations these days went through school back before MPV was really invented. In fact, I have an example back when I was working for Glastron Boat Company back in the 80s. I know that seems like ancient history. It was the last century and the prior millennia too, but we had a machine called a pin router that would route the wooden parts out that we would use in the fiberglass boats. Glastron built fiberglass boats ranging in size from about 16 feet up to about 33 feet. And you'd be amazed at how much wood actually goes into a fiberglass boat. We would have dozens and dozens and dozens of pieces of wood that went into any particular boat, in the deck, in the hull, making the seats, and so forth. And each part had a pattern, and each pattern had to be duplicated very closely, otherwise the boat was not going to turn out correctly. So these pin routers were these large tables with a motor and a router, and we would have people run these pieces of plywood through there. You could do 2-3 pieces at a time, stack up 3/4 inch ply on this table, and then move it around. It was a fairly slow process. And then they had to be dipped into a preservative material, and then they had to be put on the shelf and stored under the right part numbers for the right boats. And we were building, at any given time, we had probably 30 different models that were going down the assembly line. And so you can imagine 30 different models, each boat having dozens of different wooden pieces. The storage was immense. And you didn't want to run out because it took time to create new pieces. So you always had to have stock. Well, at that time, CNC, or computer numeric controlled routers, were just coming into the marketplace. And they were quite expensive machines, but they would replace multiple pin routers, and they would allow you to reduce your inventory to a bare minimum. In fact, you could run the next day's boats the day before and have them ready to go without any storage. It would have been an amazing time and labor saving device. Trouble is that my boss, the CEO of Glastron, Keith Orm at the time, used the payback rule. And arbitrarily, he set the payback period at 2 years. Now, I just told you these things are really expensive, and they're replacing labor. They're also replacing storage and space in the plant and so forth. But even at that, I still couldn't make it pay back in 2 years. That was just absurd. So we didn't do it. We effectively went out of business. Now, that was not only the only reason. There was a recession, and they shut down both the plants. But ultimately, we were making quite a few bad decisions based upon a 2-year payback. Had we been using an MPV rule, maybe Glastron would still be what it was. Now, mind you, if you go out and look, you will see Glastron boats, but they're being built in an entirely different plant in an entirely different way. But anyway, back to investment rules in general and NPV in particular. The advantages of the NPV rule is that it uses all of the cash flows. It also discounts those cash flows and discounts them appropriately. So NPV, it also gives us a value of the project, which is, you can think of that, if we sum those up, that would be some extra value created by the firm, right? So NPV is our gold standard. How do we do this? Well, it's simple, really, in many regards. We take the total present value of all the future cash flows, and we subtract from it the initial investment. Yeah, I know that says plus, but they're saying added a negative cash flow, right? That's a cash outflow. All right. So we estimate the future cash flows. Now, that's always a little more difficult than it sounds at first. And in fact, that's one of the problems with any investment rule, no matter what it is that we're doing these estimates with error. And if we were to do some sort of Monte Carlo simulation or a best worst case scenario, at the very least, we'd be better off. So we're looking at how much is the cash flow, and we want to know what the timing is of that particular cash flow. And we want to make sure we catch all of them, both inflows and outflows. There might be some outflows beyond the initial outlay. We also have to estimate a discount rate. And again, that is fraught with problems and error. Think about what you would get out of CAPM, but CAPM has its own problems. There are multiple other models, Fama French 3-factor, Fama French 6-factor, the Q5, various other models that attempt to help us get a handle on the cost of capital, the weighted average cost of capital. But again, we need some sort of parameter estimates around an average in order to be sure that we're getting the right estimates. And then we also have to estimate the initial costs. And actually, that's one of the easier parts of the job, is that particular thing, because we can look up what the cost of machinery is, what the cost of a plant is, and that sort of thing. Those are very tangible. Those first two items, though, are quite intangible and can be very difficult to estimate with any sort of accuracy. Then we accept the project if the NPV is greater than 0. We reject the project if it is less than 0. Also, if we have mutually exclusive projects, we can choose the highest NPV, and that will always give us the best value, the best bang for our buck. So here is an example of calculating an NPV with a spreadsheet. All right. So first component that we need is a required rate of return. We're going to do that as a decimal, and that's right down here. That is the 12% that you see in that cell. Then we're going to estimate the cash flows beginning with year 1, and that's here, here, and here. And then finally, let me get out of the way of that last cash flow. And then finally, we're going to estimate the initial investment. And then we'll use our spreadsheet formula. So it's NPV, and we open parens, and it is first the rate, and then the cash flows. And we plug that in, and we get this value. You'll notice that this mentions it's incorrect. So let me tell you the little secret about Microsoft's NPV formula. It's flawed. It has been from day one. This is 20 plus, maybe 30 years later. They still haven't fixed it. So here's the problem with it. These cash flows right here, in here, it assumes the first cash flow is 1 year from now. Oops, 1 year from now. But look at this. This first cash flow, that's our initial outlay. That occurs right now, today, times 0. Beginning of the first year, not the end of the first year. Beginning of the first year. So how do we fix that? In fact, let me go to a spreadsheet that I already have made up. I've copied this into a spreadsheet. And let's look at this in a bit more detail. Okay, so here we have that same series of figures. We have the 165,000, we have the 63,120, the 70,800, and the 91,80. We also have the discount rate, the required rate of return, and here I have calculated for you using the normal MPV formula. Oops, and I don't know why it's not letting me blow up this over here. I want you to look up in that formula line. Notice that B3, that's our discount rate. And then B2 through E2, those are our cash flows. But we're getting this $11,274.48, which I'm telling you is wrong. I'm telling you it's wrong because effectively what is going on here is that Excel thinks that this $165,000 cash outlay occurred at the end of year 1. And now my entire spreadsheet is locked up. What is the problem here? Let me close that out and open it up again. Not sure why that happened, but it did. And it's happening again. There we go. Now that's okay. Okay, well, maybe I just got locked into that formula. Okay, so let me try to get this thing to play nice. All right. I'm also going to tell you that the correct number is $12,627.41. Let me prove that to you. So, what Excel is doing, if you look down at row 5, again, if it's going to let me move, well, it isn't. Strange. There we go. Now we're down at row 5. What I have done is exactly what Excel is doing in the MPV function. It's assuming that that $165,000 cash outlay occurs 1 year from now. And then the $63,120 occurs 2 years from now. Likewise with the 7080 is 3, and then finally the 9180 is occurring 4 years from now. So what it's doing is it's underestimating the cost and underestimating the inflows as well. In this case, the inflows, when they're correctly estimated, are much greater by about $1,000 or so, not quite $400, $1,350-ish, than the original cash outlay of $165,000. So if you look down at row 6, you'll see that's properly set up. The cash outlay occurs right now at time 0, beginning of first year. The $63,120 occurs at the end of the first year. And I'm still not sure why I'm having problems with this. I am going to restart my video here and see if I can't fix this problem. I'll be right back with you. Sorry, hang on. Ah, I see what happened. Many of you probably saw it too. I was in draw mode. All right, now we're back and running. So here is the correct series of cash flows, and notice that when I sum all of those up, and notice up at the very upper left corner there, you'll see the summation. It's summing B6 to E6. So it's all the way from here to here. Okay? Now, another way I could get that is I could still use the NPV formula. Notice that's what I'm doing here, except instead of starting with the $165,000 cash outlay, I start with the $63,120 first year cash inflow. Now, and then I run out to the last one, the third one, the 9180. And then I subtract from that B2, which is the initial cash outlay. Kind of defeats the purpose of having a function called NPV. I may as well just use PV, right? Don't ask me, ask Bill Gates. That's one way to get around this issue with the NPV function in Excel. The other way to get around the issue with the NPV function in Excel is to take the, we're going to take B4, which is our incorrect value, right? That's the 11,274.48 up there that you see highlighted in kind of a greenish color. And we're going to gross that up, meaning we are going to increase that by 12% for 1 year. That's the 12% there in the pinkish highlight. And notice when we do that, that indeed we do get the correct value, the 12,627.41. All right. So keep that in mind. Be very cognizant of that when you use Excel to do any NPV. That NPV function is fraught with problems. You can use PV and just do it kind of the old-fashioned way. In fact, that's my preference by far and away. I don't like to mess around with a flawed function. Why they haven't fixed this, I don't know. Maybe that's why I'm a Mac guy. Anyway, just be careful of that. And we've got a few more things to look at on here. We'll come back to them, though. We'll be talking about IRR as well. And I've got another problem that we'll be looking at that we can use that spreadsheet for. Oops. Okay, let's go back to the slides. All right, here we are. Okay, now let's talk a little bit about payback method. Payback basically says we've got a cash outlay at time 0. And what we're going to do is we're going to, okay, so there's our cash outlay at time 0. And let's say that, just to put a number on it, let's say it's $1,000. Now, we have cash inflows in years 1, 2, 3, 4, and so on. Let's say in year 1, we have $300 coming back in. Year 2, we have $500. In year 3, we have another $500. Year 4, we have $1,000. Sorry for the noise. I have my window open here in beautiful uptown Shaker Heights and right on the boulevard. All right, back to payback. So payback says, go to the right and add up the figures. So we got 300 plus 500 is 800. Okay, so we're out here at year 2. We've gotten 800 of our $1,000 back. Somewhere about a little before midway through year 3, let's assume that these cash flows are kind of evenly distributed across there, we get another 200. And that equals 1,000. So let's just call it 2.5 years payback. Now, if, like the CEO, Keith Orm at Glasstron, we had arbitrarily set the payback for 2 years, this project would fail to meet that. Even though, look at, out here at year 4, we get $1,000. Not good. In fact, we're ignoring all of those other cash flows out there. We're ignoring well over, $1,250, somewhere in that range, $1,300 of cash flow. We're just ignoring it. The other thing that's problematic here is that we're taking the nominal values. We're not discounting them. We don't get those cash flows for a year or 2 years or 2.5 years. Money has time value. We learned that, right? It's one of the first things you learned about finance. So payback, forget payback. It's not a good rule. Yes, it's still used. Are you going to work for a company that uses it? You might. Are you going to be able to change their minds? Don't even try. Not worth it. But payback will not be a useful rule, and will not be a rule that will maximize the value of the firm or maximize the shareholders' value. It will not. Period. Full stop. Don't use it unless your boss says, absolutely tell me what it is. Many firms, I would say on average, firms have shifted away from this, but there's still some old school holdouts on this. And here's the litany of disadvantages. It ignores the time value of money. It ignores cash flows after the payback period. It's biased against long-term projects. Requires an arbitrary acceptance criteria. Why 2 years? Why not 3? Why not 1? A project accepted based on the payback criteria may not even have a positive NPV. It's problematic. It is easy to understand. Easy is stupid. It's not good. It is biased toward liquidity, yeah, but that's also not the rule. That's not what we're trying to do. We're trying to maximize profitability. We're not going to gain liquidity this way. Whatever we gain in liquidity, we're losing in profit. It's silly. Discounted payback. Still silly. Yes, it takes care of this one issue up here about ignoring time value of money. It factors in the time value of money. It says take those cash flows that we have here, that 300, that 500, that 500, that 1,000, and do a time value, discount them back to today, and then start adding them up. Still pointless. Do not use this rule unless your boss told you to do it, and then use it. And start looking for another job. IRR, internal rate of return, is a very popular measure and has some significant advantages, but is still not the gold standard, is still not what we necessarily want to use. And in many cases, we can't use it, or at least we have to do some sort of modification in order to use it. All right. So what is IRR, internal rate of return? We're finding a discount rate that sets the NPV of a project equal to 0. So we are doing NPV, mind you. But instead of using the weighted average cost of capital or the equity cost of capital hurdle rates, we're picking a rate that sets the NPV to 0. All right. Now, the acceptance criteria, again, arbitrary. Ranking criteria, select the alternative with the highest IRR. That too is problematic. We'll talk about that in just a second. This reinvestment assumption is also problematic. It says we're going to reinvest at that same high rate. Those projects don't come along all that often, especially when you pick the highest one. How are you going to reinvest at that rate? Okay, so IRR is a alternative that often gets talked about, particularly when you're talking about hedge funds, when you're talking about private equity. They use that, and it's not entirely flawed, but it does have its problems, and there are some ways around those problems. It doesn't distinguish between investing and borrowing, and either IRR might not exist at all, or there might be multiple IRRs. Which one do we pick? You're going to see an example where one is 0 and the other is 100. And we have a problem with picking mutually exclusive projects. So if we only get to do one project, just picking the project with the highest IRR doesn't necessarily increase the value of our firm, or rather, I should say, doesn't necessarily maximize the value of our firm. And again, advantages: easy to understand, easy to communicate. People love big numbers. Here's an example. So we have a cost of 200. We have a cash inflow of 50, 100, and 150. All right. And what we're going to do is get out of the way here. We're solving for IRR. Now, this is not something you want to try to do the algebra on. You want to plug this into a calculator. Use your handy dandy BA2 plus. That will do the trick here with uneven cash flows, right? We already went over that last time. So you could figure out what that IRR is. And in fact, they've already done that for us, and they found that it is 19.44%. Now, when we have very traditional cash flows, and by traditional, what I mean is that the first cash flow is an outlay, a negative cash outflow, and all subsequent cash flows are cash inflows. Then IRR has the least problems. And in fact, we don't have multiple IRRs in that situation. We would only have one. And that would be this, in this case, 19.44%. Now, if our cost of capital is 15%, obviously we take the project. Now, we could plug 15% into here, and we could actually calculate what the NPV is going to be. Obviously, it's going to be positive. So we take the project. So the decision to take or not take the project is going to be the same with IRR as it is with NPV. Here we've done a NPV payoff profile. These are kind of handy. I like this graph because it gives us some idea of how quickly we're going from a positive NPV to a negative NPV. All right. If this curve is very steep, we don't have much room for error. Small changes, if we're a little bit off, we go from positive to 0, or a little bit further off, we go down into negative territory. So really steep NPV payoff profile is not a good thing. A more shallow one is nice. This one is more shallow. Now, what you're seeing here is this same project that we just looked at. All right. So what they've done is they've said, why don't we calculate this all the way from 0 all the way up to 40%. And notice that where it crosses the 0 line, the x-axis, is right here at 19.44. That's why that's the IRR. And if we were back here at, say, 15%, this would be our NPV. Be somewhere in the 20, 25-ish range, right? If we had a lower cost of capital, say 9%, it'd be right at about 50. Obviously, at a 0%, we get 100. Why 100? Well, because we pay 200 and we get 50 plus 100 plus 150, that's 300 altogether. So 300 minus 200 is 100. So that's where this graph comes from. We just pick different rates, calculate the NPV, and plot it on a graph. We're going to come back to this in just a minute. Here, we're using that same example that we just looked at with the NPV on the spreadsheet. And what they have found for you here is that the IRR for this particular project is 16.13. Now, I have also included this on the spreadsheet, so let's jump back over there. All right, and what you'll see here, again, I apologize for how small this may be. If you're on a small screen, it'll be darn near impossible to see, but let me read that formula for you that says IRR of B2 to E2, comma, and then I put in a guess of 10%. You don't have to put in a guess, but it asks you to put in some sort of starting point, because this is an iteration algorithm that's used to do this. So it starts at 10%, and then it keeps going up until it gets to a 0 NPV, and then it reports it back, and it told us right here that the IRR on this project is 16.13%. Now, what I've done up here is I've said, all right, let's test this and make sure that this function, the IRR function, is correct. So notice I've said B2 to E2. So we're over here in column B, the 165, that's our initial outlay, all the way over to column E. And what I've done is I've discounted all of these. Now, obviously, the outlay I don't have to discount because it's at time 0. But this one I discounted for a year. That C1 up there that you see, that references 1 up here. So I took, in fact, let me just show you. I took the 63,120 and I divided it by 1 plus the IRR that I computed here in B9, and I raised it to the first power. That's the C1. All right. I did the same thing here, did the same thing here, and over here, guess what? I added them up, and I got 0. Perfect. So the IRR function in Excel is correct, and it is okay to use, because it assumes that that first cash flow is right now, times 0. Doesn't need to be discounted at all. Okay? Just wanted to confirm that with you, that the IRR is a correct formula in Excel. All right, back to the slides, and then we're going to jump back to the spreadsheet one more time because I got one last thing to show you there. All right. So we've looked at NPV payoff profiles, useful little animals. And here's that IRR. Problems with IRR. We get multiples. When do we get multiples? Well, we get multiple IRRs when we have a negative cash flow at the beginning and then a positive and maybe another positive, but then the next one is negative. And then this one might be positive and another positive, another negative. In this case, I would get 3 different IRRs because I've switched signs. It's whenever you switch signs. So here's one switch, here's another switch, here's another switch. It's from negative to positive or positive to negative. This one, and when I say one, actually, yeah, I take that back. I think we get 4 out of this because we do have another switch right here. think that'd be 4. 4 IRRs. Which one is right? They all look kind of crazy. Some of them are really low. Some will be really, really high. And then some in the middle. The other problem we have is, we don't know whether we're borrowing or lending. We also have a scale problem and we have a timing problem. Let's look at those individually. Mutually exclusive versus independent projects. So a mutually exclusive project means that the project is, we can only say we've got 3 projects, but we only have enough capital to take on one of them. Do we take the highest IRR? Not necessarily. That might be a very small project. We need to use the MPV rule in that case. Independent projects, IRR and MPV are going to give us the same answer then. And that's not a problem if they're independent. But if they're mutually exclusive, then we've got a bit of a problem. Here's the multiple IRR problem right here in living color. So we've got 1 change of signs, 2 change of signs. So we go from negative to positive and then positive back to negative. So when we calculate IRR, we actually get a 0 and we get 100%. Well, both of them look ridiculous. Both of them look ridiculous. Can't use it. Now, there are methods, and we're going to get to that. It's called modified IRR. The modified IRR is a method that says, let's make some assumptions here. Let me go back here. Any cash outflows, we're going to move all of those back. Let me clear this up so we don't get too much junk. There's a negative cash flow out here beyond time 0. We're going to move that sucker back to time 0. How are we discounting it though? Well, we're going to use the financing rate. Okay. And then we're going to take all of the positive cash flows, the inflows, we're going to move them out to the very last one. And here we're going to use an investing rate, finance rate. And then we're going to do our IRR on those two. So we're going to find the rate that will move. So we're going to move this 200. We're going to gross it up. So that'll be something over 1,000, a little greater than 1,000. And then we've got something a little bit less than 1,000 back here, right? Because we're taking that 800, moving it back. So that becomes less than 800. And we're adding it to the 200. Now we're going to take this number and this number, and we're going to set the MPV equal to 0 and find, or rather we're going to find a rate of return that sets the MPV equal to 0. That will be our modified IRR. We're making some assumptions here though. And the question is it really worth it? Why don't we just do an MPV on this sucker? That'll give us the right answer. We don't have to go through all these hoops. Besides which, there's still problems with that method. Right? Gives you a single answer, but we're making some assumptions about financing and reinvestment rates. Scale problem. I already mentioned it, but say we've got one project that returns 100% IRR and another that returns a 50% IRR. What if the 100% is on $1 and the 50% is on $1,000? Which one do we take if they're mutually exclusive? We take the 50% one. And guess what? The MPV is going to show us that immediately without having to guess. Timing problems. Okay. So here we have 2 projects. Project A and Project B. The initial cash outlay is the same. And then we have one cash flow that is identical right here at time 2. But Project A receives this really big chunk back early on. And Project B doesn't get the really big cash flow until later in the timeline. We're going to do another NPV profile plot. And Project B is the green one. So that's this guy right here. And then I don't want to use blue because that is already blue. And then Project A is this guy right here. All right. Notice that we're down here. I'm going to use blue for this. This right here is our IRR for Project B. This right here is our IRR for Project A. But what else do we see? They cross each other right here. They cross each other at 10.55%. So if our cost of capital is less than 10.55 and these projects are mutually exclusive, we would choose Project B because it's above Project A all the way back. So anything lower than 10.55 and we choose Project B. Anything above 10.55 and we would choose Project A. Well, actually I take that back. We wouldn't go into negative territory, right? We would only do that in this realm right here. As long as our cost of capital is less than, equal to or less than 16.04. Actually, I should say less than, strictly speaking. All right. So that's a bit of a problem. Now, I've got a spreadsheet here that we can look at that has this shown on here. Let me show you what I'm talking about in spreadsheet terms. So I've got Project A here on row 12, and I have Project B on row 13. There are the cash flows that you just saw. Come on. The responsiveness of this is dubious. All right. Come on, wake up, wake up. Now I have more. And it's not because I'm on draw. There we go. So what I've done is I've said, well, let's calculate the NPV at various rates. So at 10.55, notice that Project A and Project B have nearly the same NPV. Well, that's that crossover point, right? And it happens to be around $604. And the only reason there's a little bit of a difference there is that that 10.55 is actually, there's some additional decimals beyond that, the 55. We could get it exact by changing that 10.55 a little bit. Now, if I were to go down to 9, think back to the left on that NPV profile plot, that's when Project B shines, because notice here that its NPV at 9% is $1,025, whereas the NPV of Project A is only $788. Likewise, the opposite of that occurs at 12%. So if we go up here, oops, back on draw. If we go up here at 12%, Project A has the higher NPV, 437 versus 231, and by quite a bit. Both of these are by quite a bit. So again, if these are mutually exclusive projects, I would not want to use the IRR rule to make this decision. I could very well pick the wrong project or pick the project that doesn't maximize my shareholder value condition on this new project. Okay? All right. Back to the slide deck. Sorry for all this back and forth business here, but I want to make sure that you get a really clear picture about what's going on here. All right. So, both NPV and IRR many times give the same decision. The exceptions, as we've just noticed, are when there are non-conventional cash flows, signs change, and then in the case of mutually exclusive projects, especially when you have a crossover that is above the zero line on NPV, then we don't want to use IRR, we want to use NPV. Right? Another type of investment rule that somebody dreamed up is the profitability index. So here it also uses the present value of all the cash flows, and it scales it by the initial investment. So as long as the profitability index is greater than 1, in other words, the numerator, the present value of the cash inflows, is greater than the denominator, that is the cost of the project, then we take it. And again, this measure, just like IRR and NPV, many times will give you the same answer as NPV or IRR. You'll pick the right project. However, again, with mutually exclusive projects, you don't know the size. It's a scale problem. You've got a number, but you don't know what that scale is. It's scaled by the denominator, by the cost. So, not good for mutually exclusive projects. It is useful when available investment funds are limited. It's easy to understand, and generally speaking, makes the correct decision for independent projects. So if we can take both projects or all three projects, it'll give us the same answer. But it gives us the same answer as NPV, so why bother with it? Other than if your boss was trained in this and your boss says, we're using profitability index, and you just go, okay, yes, sir, or ma'am. We will do that. All right, practice of capital budgeting. Some firms still use payback rule, while others have chosen alternative approaches like NPV or IRR. Most frequently, large corporations are up to speed. So many of you are going to be working for major corporations, Goodyear, Sherwin-Williams, Progressive. They all know this story. But smaller corporations, maybe not so much, like my experience with Glastron. We're going to do a quick little example here of how the investment rules compare between two projects. So we've got Project A and Project B. That's the same, or at least Project A is the same as one that we've looked at previously. Oh, and so is Project B. We're just going to calculate the IRR, the NPV, and the PI and the payback for these, assuming a 10% cost of capital. Obviously, we don't need that in the case of IRR, but we do for the others, at least for the profitability index and for the NPV rule. Okay, so calculating NPV, we get 41.92 and 90.80. If these are mutually exclusive projects, Project B is our project. In the case of IRR, this one, remember, the sign's changed. There's 1, but there's 2. So 1 right here, and then another one right here. So it's either 0 or 100. Who knows? Project B doesn't have that problem. There's that 1 change, so we get 1 IRR, and it was 36.19%. And then the PI, Actually, notice that it's giving the same answer for the compared to the MPV. We should take project B, but that's just by chance. Not going to always be the case. It could be that these were reversed, and ideally we would still, if we had had an investments class within the last quarter century, or 30, more like 30 or 40 years, we'd still want to take the MPV and use that. Payback. Okay, so we've got project B with a payback of 2 years. Project A, though, even payback can have multiple paybacks. So it's either 1 or 3 years, depending upon whether we look at this. There it's 1 year. But if we go out further and we see this one, there it's 3 years. Bizarre. Do not use, please. Like I said, unless your boss says you must. And then just some here basically what they're doing here is creating. You could plot this and get that MPV profile for projects A and project B. They actually started at minus 10%. I'm not sure why. That doesn't make any sense, but nevertheless. So you'll notice that here's where we get that 0 IRR. And then it starts going positive. And then here we have, it starts to go negative once we get up above 36 was the 36.19, I believe, was the IRR. So that's the point at which this starts flipping signs from a positive MPV to a negative MPV project. And then here's the plot. So they've done that plot for us. And notice that this is that multiple IRR for project A. Project B just has that single IRR up there at 36.19. And I'd be much more comfortable with, I think, project B in general. That weird 800 expense out at year 3 that's what's making this line go flat in the middle. I don't know. I take that back. I have to reserve judgment. It would depend largely upon what our cost of capital was. If our cost of capital was really high, I was out here, I don't mind that flat spot there. That's okay. If our cost of capital was a little bit lower than, say, here, then I'd very much prefer to have something in that range. So I think I would switch. I would pick project A up until about 15% and then switch over to project B if they were mutually exclusive. And that's pretty much it for the chapter on NPV and other investment rules. It's chapter 5. And if you have any questions, want any clarifications, make sure that you jump onto Canvas, get into the discussion forums, and send out a question. If you happen to know the answer to that question, or at least you want to take a stab at it, no charge there. I mean, I don't subtract points for taking a chance and trying to answer a question. I'll try to get in there as often as I can to check answers if you've made an answer and make any clarifications or adjustments to that. But feel free to try to answer a fellow student's question. If not, I will be checking that on as regular a basis as I can, depending upon my access to Wi-Fi. So I will see you next class. We'll be talking about Chapter 6. We're going to stay in this capital budgeting thing for a while. We've got Chapter 6 and 7 as well. So I will see you then. Take care.